Hey everyone, welcome to today's Explainer. We are diving right into Robotics I and II, specifically hitting Unit 02, Sensing and Environment Response. If you're a grade 7 learner working through your STEM pacing guide, or honestly, just someone who's super curious about how machines actually think, you are in the absolute right place. Today we're going to do a really crucial misconception check. We need to figure out how robots actually interpret the commands we give them. It's not always what you'd expect.
So I want you to picture this. Imagine you're gripping a remote control, right? You push the joystick forward, the robot zooms forward. You flick it left, the robot whips left. It feels pretty awesome, doesn't it? You feel like you're the absolute master of this machine. But we really have to ask, who is actually driving the robot here? Is it 100% you, or is the robot maybe doing a little bit of the driving itself? When you hold that remote, do you honestly have total control every single second? Well, let's unpack that.
Okay, let's start by locking in some foundational vocab for Unit 02, a sensor. Simply put, a sensor is a device that reads input data to allow a robot to detect and then respond to its environment. You can think of sensors as the robot's eyes, its ears, maybe even its sense of touch. And they aren't just there to look cool, they are highly active components. They're constantly, and I mean literally constantly, gathering live data from the physical world so the robot's computer brain knows exactly what's going on around it.
And that brings us straight to the core focus of today's Explainer, our essential question. How can a robot use sensor data to respond to its environment? Now, what's genuinely fascinating about this is how we're going to apply it today. We aren't just talking about those fully autonomous robots wandering around an empty room all by themselves. Nope, we're going to see exactly how a robot uses that sensor data when you are the one mashing the buttons on the remote control.
So, there's this huge myth out there in the robotics world, and we really need to bust it right now. The myth is that the second a human picks up a remote control, the robot's onboard sensors just switch off. People kind of assume the robot's brain just goes to sleep because the human is supposedly in charge. But the actual evidence? It shows us something completely different. The reality is that remote commands combine with onboard sensor safeguards. Because, let's be real, sometimes we humans aren't the absolute best drivers, right? Using a remote control doesn't mean the robot stops sensing. It actually creates this incredible partnership between human and machine.
The really critical point here is figuring out what happens when that partnership, hits a bump in the road. I want you to actually take a quick second to pause and predict what happens when your manual command from the controller completely clashes with the live input data the robot's sensors are reading. If you're saying one thing but the robot's sensors are screaming another, who actually wins that argument? Let's take a look.
Let's walk through a concrete example to see how this plays out in the real world. Okay, first, you, the human operator, confidently hit move forward on your remote. But at the exact same time, the robot's onboard distance sensor detects a massive solid brick wall right in its path. So you're commanding go forward, but the sensor data is yelling wall ahead. Because of this clash, a sensor-based safety override kicks in. The robot processes the data, realizes your command is going to cause a catastrophic crash, and it just automatically stops moving. It completely defies your remote command just to protect itself.
And this right here perfectly illustrates the massive aha moment of our whole lesson. The robot prioritizes sensor-based safety overrides over human error. You see, sensing and remote control, they aren't mutually exclusive. It is not an either-or situation at all. They form a super-intelligent combined system. You, the human, provide the general intention, like, hey, move across the room, but the robot is actively using its own sensors to keep itself safe while it carries out that intention.
Let's quickly hit our key takeaways and see how this all ties back into our unit. Number 1, sensors are constantly reading input data. Even when you've got the remote in your hands, they definitely do not take a nap just because you're steering. Number 2, remote control and sensors work together in tandem. And number 3, those safety overrides protect the robot from environmental hazards that you, the operator, might have totally missed or accidentally steered right toward. This perfectly answers our essential question. A robot uses data to respond to its environment basically by acting as its own built-in safety net.
Now, before we wrap this explainer up, I'm leaving you with a transfer challenge to really test your grasp on this combined system. Imagine you're holding the remote again. You firmly press forward. But this time, the robot is driving on top of a table, and its downward-facing edge detection sensor suddenly sees that the table is ending. There's a steep drop-off right there. Based on everything we just learned about how a robot responds to its environment, you got to think about the logic here.
Does the robot blindly listen to your controller and just take a dive off the edge? Or does it trigger a safeguard? I'll let you chew on that one. Thanks for hanging out with me today and keep questioning how things work.